Welcome to the DIY Honda Garage channel. The DTC P0615 indicates a malfunction in the starter cut relay diagnosis circuit. This problem can prevent the engine from starting or may not allow the starter system to function properly. The starter cut relay is a crucial component that ensures the engine's starting system operates reliably. In this particular model, the relay is located within the under-dash fuse/relay box of the vehicle, which makes access to this component vital for diagnosing and addressing the malfunction. Additional components involved include the powertrain control module, PCM, which manages communications and control for the engine's electrical systems. Therefore, identifying the cause of this DTC is essential to restore normal operation of the vehicle. The DTC P0615 signifies an issue with the starter cut relay diagnosis circuit. This circuit is vital for the operational integrity of the starter system, ensuring accurate communication between components. The starter cut relay, situated in the under-dash fuse relay box, controls the flow of current necessary for the starter solenoid to engage and crank the engine. The powertrain control module, PCM, plays a fundamental role as it oversees various electrical functions and diagnostics, and any interruption in signals or malfunction in the relay can trigger DTC P0615. Effectively diagnosing this code involves looking at both the relay and PCM, as well as the associated wiring, to ensure all connections are secure and functioning as intended. Understanding the potential causes of DTC P0615 is essential for effective troubleshooting. A malfunctioning starter relay can prevent proper operation, leading to a failure in starting the engine. Additionally, poor circuit connections or terminals that are loose may disrupt signal flow, causing the system to malfunction. An open in the start diag wire, which connects the relay to the PCM, can also cause this DTC to appear, as it indicates a break in the circuit. Lastly, a blown fuse or a short in wiring could result in insufficient power reaching the relay, directly impacting the engine's ability to start. Identifying these issues is crucial for thorough diagnostics. A vehicle experiencing DTC P0615 may present several symptoms that indicate an issue with the starter cut relay. The most apparent symptom is that the engine will not start, often accompanied by no power reaching the starter motor. Some users may experience intermittent starting issues, where the vehicle may start at times, but not at others, complicating the diagnostic process. The DTC itself will display on the Honda Diagnostic System, HDS. During troubleshooting, which verifies the need for further inspection, recognizing these symptoms allows for timely intervention to address the malfunction before it escalates into a more significant issue. In the first troubleshooting step for DTC P0615, you will begin by verifying the initial condition of the vehicle. Firstly, turn the ignition to the on position to power the vehicle systems, and clear any existing diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. After clearing the codes, attempt to start the engine and observe the results. Once the attempt is made, check again with the HDS for the presence of any confirmed or pending DTCs. If DTC P0615 reappears, it indicates a persistent problem that requires further investigation. Conversely, if no DTC is present, it may suggest intermittent issues requiring a closer examination of the circuits and connections. In this step, we need to check for additional DTCs that may be related to the initial P0615 code. Using the HDS, scan the system for the presence of pending or confirmed DTCs, such as P16F3 and P16F4, which indicate low voltage issues in the starter cut relay control circuits. If either of these codes appears, it necessitates troubleshooting specific to those codes, as they can provide further insight into potential problems within the starter cut relay circuit. If neither DTC is detected, you will proceed to the next troubleshooting step, focusing your efforts on isolating the fault in the circuitry or connections associated with the starting system. Now, we focus on examining the start diag line, which is crucial for the starting process. Begin by turning the vehicle's ignition to the on position once again. Clear the DTC using the HDS to ensure no prior codes are influencing the new diagnostic session. After clearing, try to start the engine. This inspection helps determine whether the issue lies within the starting system. If the engine starts successfully, proceed to the next step, where additional checks will be performed. However, if the engine fails to start, additional diagnostics are necessary to identify the root cause of the failure. In this step, we perform a critical check of the wire integrity in the start diag line. First, turn the vehicle to the off lock position to cease any operations and ensure safety during testing. Next, use the HDS to jump the SCS line and allow it to sit for more than 1 minute to stabilize the reading. After completing these steps, disconnect the connectors from the PCM A51P and the relay circuit board A8P. Subsequently, check for continuity between designated test points to verify if the circuit is intact. Test point 1 is on the relay circuit board connector A, terminal number 8, while test point 2 is on the PCM connector A, terminal number 47. If continuity exists, it confirms the start diag line is functioning properly. The next step involves checking the integrity of the fuse responsible for the starter cut relay system. Begin by ensuring the vehicle is in the off lock position to turn off all electrical systems safely. Locate and inspect fuse number D20, 10 grams, situated in the under-dash fuse relay box. This particular fuse protects the circuit supplying power to the starter cut relay. If blown, it will prevent operation. If the fuse is intact, you will then need to investigate for any shorts in the IG1 starter cut wire running between the D20 fuse and the relay circuit board. In case the fuse is blown, replace it. And if the wire checks out, you may need to replace the under-dash fuse relay box. Continuing with the diagnosis, we will now examine the integrity of the IG1 starter cut wire. Disconnect the under-dash fuse and relay box connector C27P and the relay circuit board connector B6P to isolate the circuit. Next, jump terminal A of connector C27P to a body ground to establish a reference point. After completing this, check for continuity between test point 1, relay circuit board connector B, terminal number 4, and the body ground. If continuity is confirmed, it indicates that the IG1 starter cut line is functioning correctly, and you can proceed to the next diagnostic step. Conversely, if there is no continuity, it suggests an open circuit that requires repair between the relay circuit board and the under-dash fuse relay box. The final step in this series involves checking the relay circuit board itself. Begin by removing the relay circuit board from the vehicle for thorough testing. Assess the relay to verify its operational status, since a malfunctioning board can result in failure to power the starter solenoid appropriately. If testing confirms that the relay circuit board is operational, then you will replace the under-dash fuse relay box as needed. However, if the board is found to be defective, it must be replaced to resolve the DTC P0615 issue. This concludes the troubleshooting for this specific DTC, ensuring the engine starting system is restored to proper functionality. After completing all necessary repairs related to DTC P0615, It's crucial to verify the effectiveness of your fixes. This begins by reinstalling any components that were removed during the troubleshooting process, ensuring that all connections and terminals are secure. Once everything is back in place, you will use the HDS to clear any remaining DTCs from the system. Following this, attempt to start the engine to confirm that the issues leading to the DTC have been resolved and it starts without any hindrance. Monitoring the HDS for the presence of DTCs during this test will further validate successful repairs. This step ensures that the vehicle is roadworthy and that potential issues are proactively managed. To prevent issues related to DTC P0615 from recurring, incorporating a preventive maintenance routine is essential. Regularly inspecting cables and wiring associated with the starting system will help identify potential wear or damage before they lead to malfunctions. Additionally, the connectors should be checked periodically for loose terminals or corrosion, which can impair electrical connections. Monitoring the integrity of fuses, specifically those related to the starter cut relay system, is also important, as it can prevent unexpected failures. Keeping the vehicle systems clean and properly maintained will enhance longevity and reliability. Staying proactive in maintenance can save time and costs associated with significant repairs down the line. In summary, DTC P0615 points to a starter cut relay diagnosis circuit malfunction, essential for controlling the starting system. Understanding its components, primarily the starter cut relay and PCM, is crucial for effective repairs. A structured troubleshooting approach, as outlined in this guide, allows effective identification and resolution of issues causing the malfunction. Furthermore, regular maintenance practices ensure long-term reliability and prevent recurrence of similar issues in the future. Overall, the key takeaway is that diligent diagnostic processes and preventive measures are fundamental in maintaining the Honda CRV starter system functionality. Engaging with a professional mechanic when unsure can also streamline repairs and enhance vehicle safety. Please like and subscribe to the channel. See you next time.